Good morning again, ma'am.
Good morning, sir. Good morning, Arun sir. Jai Hind.
Morning, Prachi and all the team.
You're now connected to both now.
Good morning, all students. All prepared?
Young mathematicians.
All mathematicians. Yes, yes, yes.
Good morning.
Good morning, Jai Hind.
I'll think everyone forget the COVID culture of the wishing. Anyone? Yes, students.
There is lots, sir, which they can do online.
Okay, then why you are missing? Everyone, please. When you learn something good, something new, then continuity is important.
Yes, yes, yes. Sir, before we start, मैं कुछ rules बता दूं बच्चों को?
Yes, ma'am. Sure, ma'am.
Yeah. Team Cosmetric was first, so they are presenting first Bright Future of Shantipura School. And the other two teams are also listening, I think Team Brahmagupta and Team Acoustic. So they will be giving two brutals also. They'll be coming at the end of your presentation and they will be giving two brutals, means they'll be asking you two questions. Plus Arun sir, Sneha ma'am, all of us will also be asking you questions. Okay, and just make sure that your slides move while you're speaking. Yeah. Sir, Arpita ma'am is not there?
No, ma'am, she is not well.
Okay, okay, okay. Fine. Sneha ma'am, are the kids ready to start?
Yes, ma'am.
Okay.
Good morning and Jai Hind everyone. Today, with the team Cosmetics, are present here again to present our case study, which is about a Shantipur school, which is a school in a rural area. So, this is the first slide. It tells about how the solar energy, community support, and development and school development will provide us the opportunity to have clean power access, improved facilities, and a bright future. Moving to the next slide.
Good morning and Jai Hind, everybody. This is Shrijit and he is Ayansh Vikram Singh, here to explain the maths behind all of this. So let's start. So as of our proposal in the case study, we get to know that we will be using solar energy in this particular topic. Now, how will it work? What is the maths behind it? How will it calculate all of the things? To explain it, I would like to call up Ayansh.
Good morning and Jai Hind once again, everyone. This is Ayansh with my friend Srijit to show the maths behind this. We know that that is given that number of panel we have to find, and each panel produce 0.3 kilowatt of energy, or in the power cut of 5 hour, it will produce 1.5 kilowatt of energy. So the number of total panel will be 60 by simply dividing it with 90. Now, area of each panel is given, that is 1.6 meter square, and and uh, and area of 60 panel will be 96 meter square. Now, now we have to find the cost of 60 panel. The cost of 60 panel will be 5,70,000, as each panel costs 9,500. Now, total cost, adding the inverter and wiring cost and installation cost, will be 7,70,000, as government subsidy is 20%. So the government subsidy value will be 1,54,000. Now, on decreasing the subsidy, the value will be 6,16,000. The investment has a payback period of approx 3.8 years. Now, for the next slide, here comes Srijit again.
Now here I am again to explain this part in a more brief way. So start off, we have panels that are about 5,70,000, as my friend Ayansh told that the calculation above. The inverter and wiring cost will add up to like 1,20,000, and the installation will add up to 7,70,000. So after the subsidy given by the government, that is the 20%, so we will find it after subtracting 1,54,000 of the above, it will be 6,16,000. Now, after we have paid this sum, the school has paid this sum, that is 6,16,000. To recover this, it will take around 3.8 years. Now you will ask how? So each year the school pays 14, each month the school pays 14,500 as the electricity bill. That will add up to 12 months for a single year. And that after we divide all of this, it will break even to 3.8 years in getting back the money that we took it as an investment. Now, after till the optional payback, after we have done all of this, we have added a pie graph here to showcase these things. Now, moving ahead, let us see how we can add up more energy in this plant. For example, in the winter season and in the monsoon season too, the rays coming from the sun are slanting and we are not able to get all of the energy. So here we propose one thing. We will install, here we have showed the diagram as you can see on the screen. We will install the panels at a certain angle of 70 degrees so that it captures most of the energy. For example, the flexible tilt mounts, as the slide says over here, will increase the production rate by up to 12%, increasing the 90 kilowatt that we were getting per day to 100.8 kilowatt. That will be really fruitful for the school in case of extra energy using scenarios. Now, this will ensure higher generation, that is up to 36,800 kilowatts, and better reliability in winters and monsoon seasons when the sun is not really that much high and we are not able to extract that much power of energy. Now, moving ahead to explain more about this powering and powering here, I would like to call Parth.
Jai Hind everyone, I hope you all remember me. Last time I came here to explain more of a thing about nature and explaining about natural beauty. But now I'm here again to explain a thing about the solution to save this natural beauty. So let's start with example again. For example, you're sitting in Shantipur school, you have the solar panels at the rooftop. But what if there's a rain? What if you are stuck with a fog in the season of winters? The solar panel would really work. But what can you do? Guess what? We have a solution that stays in EMS, that is energy management systems. It has mainly lithium batteries and all, and the lithium batteries in simple are very costly. So at start, I want to make it clear that you got a need of funding, and it is very practical because you can't really use the solar panels for 365 days due to rain and all other problems. So talking about the price and all, the lithium batteries and the whole of EMS systems cost about 10 lakhs, and they produce about 45 kilowatts of battery bank. And when you add up with the solar panels that are 6.72 something, then we can take it as a prox of 17 lakhs. And when you want to get the savings back as much you invested, then you have to get of a time of about 10.5 years, I think. Then the total approximation would be 17 lakhs, and you will get all the returns of your as your savings in 10.5 years, and take a sustain till 25 years. But why only use all those lithium batteries and all? They are very costly. Why don't we use generators? Well, guess what? Sit in front of a generator for 5 minutes, you start to suffocate. Same is with the whole of a practical thing. For example, you have a generator. Most of the schools have generators, but the generators, emit a lot of carbon. But if you use solar power, you can save up to 29.6 tons of CO2 emission in a year and 750 tons over 25 years, which is equal to sum of 30,000 approx of trees in a year. Then you can say it of about funding. Where can you get the funding from? There are a lot of companies, the corporate sectors, the government's giving subsidies due to SDGs and all, and all other things. We have put all the ways of getting a funding in our slides. That is Selco Foundation, Solar Aid, Barefoot College specialized in rural school electrification projects and provide invaluable support. Alumni support. There's a lot of students who must have been very educated and went to different sectors, and they can give funding for the same. I've also aligned all the SDGs we have, the quality education, SDG 4, clean energy, SDG 7, SDG 13, climate action. At last, I would end it with a rhyme again. That is, if you see a problem and it's actual, you gotta make it practical. Thank you. Back to my friend Hriday.
So, hello everyone. As you would know right now that I recommend you these three things right now. Installing 60 solar panels is our need, and what is a want is installing 70 solar panels so that we can cover the external needs that a school needs after some development and anything. Leveraging government subsidy. So, as you can see, we can take government from loans from the government, but even though they are minimal, we also need some more loans. So to cover that, we can take loans from NGOs or another organizations so that we can reduce the load on the school. And by following all of this, we can foster a green, clean learning environment because we can reduce the carbon emission and provide a better future for the students. And at last, I would like to talk to you about the sources. We have the source of IEA organization. It is the organization it is a link from by which we have calculated the carbon emission of coal, 1 kg of coal, which is 0.9 kilogram watt per hour. And for Wikipedia, we have calculated another finite options. And by Grammarly, we have used Grammarly for the spelling checks. I would like to conclude this case study. Thank you all.
Nicely presented, Team Cosmetrics. Can we have some questions?
Yes, Team
Yes, sir.
Cosmetics. Are you ready? Hello.
Yeah, sir.
Yeah.
Okay. How you justified that there is only 20% discount or subsidy in the panel on the panels?
Sir, can you repeat? Your voice was not clear.
How you justify that there is only 20% subsidy on the solar panel?
Sir, actually, the case study that we were given in it was written that 20% of subsidy was provided by the government. And
From which source you get this knowledge, this data?
sir, actually, it was mentioned in the case study that we got.
Which case study?
Ma'am sent. We got it by Prachi ma'am's side.
Sir, it was Bright Future for Shantipura School.
Then
That
mention
was,
that.
yeah, in that
is
they
important.
have mentioned that the government subsidy is 20%.
We have also mentioned some external source for the
Are you mention any maintenance charge?
Yeah,
Yes,
they did
yes,
not
Yes,
talk
we
about
mentioned
it.
12,000. We talked about it.
We talked about it, sir. 12,000 was management cost.
Ayansh talked about it in his
Yes,
side
sir.
of the calculations.
Acha, good. And then last query, is there any NGO who provides loan?
So please
You
repeat.
mentioned your third partner announced that you can get loan from the NGOs.
Yeah.
Yes, sir. Yes.
Yes, what?
Part knows about the NGOs. We did some research on the
Yes, sir.
internet.
The Selco
Which
and
NGO?
Barefoot College and all are the sources for funding and all. And you can also get the government subsidies as there's already in the case study.
No. I'm clearly asking: is there any NGO in India that provide loan to any
Yes, sir.
consumer? Which
Selco.
NGO? Selco is NGO?
No, sir, but it provides for the.
No, Be clear, beta.
So it
Selco
provides the funding, I said.
It provides the funding, sir. It provides
Provide bank also provide funding. Government also provide funding. So many. But I am asking of the
But it's for
NGO.
but it's specifically for the environmental friendly things, sir.
Sir, we
Then
can also take fundings from the Department of
no, no, no.
Renewable
My
Energy, sir.
query is only: is there any NGO, non-governmental organization in India that provide loan for the solar panel?
Sir, it is there, but I don't really know the names.
Then how you
Yes, sir,
say that?
there are.
Which NGO?
SELC.
SALCO. Sujit said it.
This is
Sir, we have
NGO.
mentioned in the PPT, sir. If we go, yes, sir, we got to know on the internet what information we got on the internet. We just disclaimer. We delivered it to you, and at the last we also mentioned the sources that where we have taken the information.
If any agency provide loan, then how you can say that this is NGO? This is not profit organization.
Yeah, the NGOs do not generally provide
NGO means
funding.
non-profit organization.
Organization.
Okay, then be clear about that. Okay, rest good. Your data is good. Your effort is good. Okay, and
Okay.
make a habit in any presentation to include the source of the knowledge from where you get this knowledge.
Sir,
Also
we have
mention it
mentioned the
at
source at the
the
last.
bottom
Can
of your
please-
slide.
So
Sir,
there are the
May I
sources, sir.
speak? So can I
Yeah,
speak
yeah.
something?
Yes.
Sir, at the last page, when you see the thank you in at above, at the top, there's sources that is lee.org, kg of coal, wikipedia.org, and Grammarly for spellings.
Once
Sir, we
again,
have mentioned
Sobi. Once again, please, Sobi.
Sir, at the we have shared the screen and there's sources mentioned. That is lee.org, kg of coal, and wikipedia.org for financial options, and Grammarly for spelling checks.
Okay, good. Try to include more resources. Okay, and the authentic and government body is the important thing.
Sir, that's why I mentioned the Department of Renewable Energy.
Okay, and what is MNRE? MNRE.
Yes, sir, the Department of Renewable Energy. It can provide the subsidies, sir. If we
What is the full form of MNRE?
Management of Natural Resources and Renewable Energy, something.
Ministry of.
Ministry of Natural Resources and Renewable Energy.
Good.
That's what.
Okay.
Okay, good try, Cosmetrics. I have one question. You did not talk about the CO2. How much is the CO2 avoided due to the solar panels? Did you talk about it?
9.6 tons per year and 750 tons in 25 years.
Sir, ma'am, we showed it in the graph that Parth explained.
Ma'am, it was in the graph. Let me show you. Can you see the graph? It was in the graphs, ma'am. We had made some graphs about it, and we have a rough sketch of 29.
We have written it over here, as you can see, of avoidance of 29.6 tons of CO2, which sums up to 750 tons over the 25 years. My friend Parth also explained it in his explanation.
And which adds up to be 30,000 trees in 25 years about.
This adds up to planting like about 30,000 trees.
That's good. One more question which I have. That's like, what is the use of this case studies in academics? How do the case studies help in any academic case study teaching?
Ma'am, may I answer?
Yeah.
It improves our, first of all improves our critical thinking. We are able to analyze situations. We can do better research. We can gain more things. We learn to analyze more things. We learn how to check more resources. And last of all, we get more creative. For example, while making this presentation, while preparing the graphs, we thought of what to show you and what may sound good or may sound interesting. For example, the fact that 750 tons of avoidance of CO2 is equal to planting of like 30,000 trees. So that was a fact that we thought was really informative and was good. So we told you the same.
We also added a lot of practicality, ma'am, because I don't think a solar panel can sustain about 365 days because of the rain and other things. It was the main perspective I was thinking of the whole of this case study.
It was not mentioned in the case study about the monsoon and the winter's days, but we still added the flexibility thing and the panel covering so that we are able to, relate with the situation and be practical.
Okay, so and basically case study also encourages collaborative learning, teamwork. You all
Yeah.
learn to work in a team also. So that is because of the case study that you got. Yeah.
Yeah.
Nidhi ma'am,
Sure.
you have any other
I have a
questions?
question, team. Yes. First solar power plant of India. Team, I have a question for you. Which is the first solar power plant of India?
Okay, Odisha.
Karnataka, yeah, Odisha. Ma'am, Karnataka or Odisha, I think, not sure.
No, 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 no.
Hyderabad. Anybody has an idea?
Andhra Pradesh, Telangana.
Yeah.
Andhra Pradesh, Telangana.
बोल दे भाई, बोल।
Jharkhand?
Sorry?
I don't, ma'am, I don't really think, but it could be Jharkhand.
It's Jaisalmer, Rajasthan.
Okay, ma'am.
Ma'am, we didn't know that.
Recent, just 1 month before, government plant at the Jharkhand. This is the
Yeah,
last one.
that's the recent. So,
Okay.
okay, one more question. Do we have any village which is completely empowered by solar plant
Ma'am, we
in
don't
India?
really, actually.
It's there. It's Modera in Gujarat itself, which is completely empowered by solar power plant.
Okay, ma'am.
Okay, ma'am.
That was really
So the
informative.
thing is that whenever you do a case study, you go with deep analysis, not just only given data. Okay.
Okay, ma'am.
Just the given data, if you take out the question, then the solutions will not help. What is related to it, where it was, how was it done? So those things you have to consider.
Okay, ma'am.
Yeah.
We will surely
Okay.
look on it. Thanks.
Okay.
More important thing is the study.
Yeah.
If you're presenting your case study in 8 minutes, means minimum, what is say, 8-hour study is required, minimum. And there is no limit for the maximum. So the several journals, at last you do Google for the data. And first you search the journals, proofed journals from the, so many books are there, government sites are there, then you decide. Good.
Yeah. Do we have team Brahmagupta and team Acoustic Delta for questions, for rebuttals? Team, only
Yes,
one team
ma'am.
is going to go ahead. Yeah.
We have questions that which type of solar system they have used. They have used on-grid solar system or off-grid.
Oh, on great.
On-grid solar system.
Can you explain why you have used on-grid solar system instead of off-grid solar system?
Because it is more reliable and it produces more energy, and that's the sort of thing that we took upon.
Okay. Team Acoustic Delta.
Ma'am, we don't have any queries regarding this. Thank you.
Oh, great. So you're letting your team, the other teams win. You do not have any questions for them?
No,
Good.
ma'am, it's just an healthy competition, but we don't now have any queries.
Okay. Okay. So you tied up. Team Cosmetric is also not going to ask Team Acoustic Delta.
No, ma'am, there's nothing like that. I mean, they didn't have any questions. That's their choice.
Okay. Okay. Fine. Fine. Now we move to Team Brahmagupta. Good. Team Cosmetric. Good work.
Thanks a lot. Thanks a lot, ma'am.
One more question for my side to Cosmetric.
Yes, sir.
Okay. Your break-even period is around 4 years. If the government suddenly remove your subsidy, how would that affect your financial analysis? How would that affect your would solar still remains for the best option or any other alternative you have?
Yeah. I asked. Sir, I asked critical question.
Yes.
Sir, if the government removes the subsidy, the total cost will be 7,70,000, and the
Okay.
time to recover the amount will be some like 5 years or more than that.
More than 5 years.
Yes, sir, maybe about
More than
about 5 years.
is it okay? Just check your calculation again. Okay, right. Thank you.
Thanks.
Next team.
So good morning all of you. I am Sriyan of Team Brahmagupta, present here to show the presentation on our case study, which is smart farming for sunrise. As we know, farming is the backbone of our nation, and smart farming is its future. Now moving forward to the next slide. Background and problem statement. So the context of our topic is Sunrise Farmer Cooperative have 120 farmers which have newly acquired land of 50 hectares near Bhavanpur, and the region has limited rainfall and irrigation costs are rising there. And the crops we are considering here is wheat, rice, and vegetables. And the problem is we have to decide how many hectares we have to allocate to each crop to maximize the revenue without exceeding land, water, and our budget limit. So the data provided here is for the crops wheat, rice, and vegetables. First, wheat. The wheat has water availability of 4.5 million liter per hectare and yield 3.2 ton per hectare. And the market price for wheat is 18,000 rupees per ton. And the cost per hectare cultivation of wheat is 55,000. And same for the rice, like 8 million liter per hectare water and yield is 4.5 ton per hectare, and the market price for rice is 22,000 rupees per ton, and the cost is 70,000 rupees per hectare, and so on with vegetables. So, and the resource which have been given to us is the total land is 50 hectares and total water available is 300 million liters, and the budget for our cultivation is 45 rupees lakh. And moving forward to the next slide. The season variables and the constants. Decision variables, we have taken variables to for the values of wheat for hectares of wheat and hectares of rice for R and V for the hectares of vegetables, and the constants are first land constants. The hectares we are using for wheat plus the hectares we are using for rice plus the hectares we are using for vegetables should be equal to 50 hectares are less than 50 hectares. It should not exceed than 50 hectares. And the water constant for liters, water in liters is 4.5 million liters for into the hectares we are using for the wheat, plus the 8 million liters water for the hectares we are using for rice, plus 6 million liter water for the hectares we are using for the vegetable. And it should not be greater than 300 million liter water. It should be equal or less than 300 million water. And the budget constant for the per hectare of wheat is 55,000, and rice is 70,000, and wheat vegetable is 80,000. And it should not exceed the total sum of their budget, should not exceed 45 lakh. It should be less than 45 lakh or equal to 45 lakh. And we have to take all wheat, rice, and vegetable some hectares, because we cannot skip any one crop. From now onward, my friends Anshuman will tell.
Good morning and Jain everyone. I am Anshuman from Team Brahmagut, and I am going to explain the objective and functions and revenue calculation for our project. So we are going to calculate our revenue per hectare according to the formula that we are the yield multiplied by the price, the market price. So according to the given data, the wheat we are 3.2 tons, and if we multiply it with the market price, we get 57,600 rupees per hectare. Same with rice, we are getting 99,000 rupees per hectare. And from vegetables, we are getting 1,50,000 rupees per hectare. And our objective is to maximize the revenue without using much water and budget. Now I'm going to show you the another data, that is how much revenue we are generating per million liter of water uses. To calculate the per million liter of water uses, we must divide the revenue per hectare upon the million of water use. So if we divide 57,600 from 4.5 million liter of water, so we can calculate that for wheat we are using 12,800 rupees we are generating revenue per million liter. And for rice, we are generating 12,375 rupees per million liter. And for vegetables, we are generating 25,000 rupees per million liter. And if we want to calculate the profit, so we know that profit is equals to revenue minus cost. So from this, we can calculate that for wheat, we are cost is 55,000 for cultivation. So if we subtract it from revenue, we will get for wheat is 2,600 per hectare. And for rice, we are getting 29,000 per hectare. And for vegetables, we are getting 70,000 per hectare. So here is a takeaway that the vegetables are highest revenue generators, and it uses less water and it generates high revenue. So we are using more hectares for wheat. Now I will show you the Excel sheet to calculate how much revenue we are generating. So like if we are using 12.5 hectares of land for wheat and 7.5 hectares for rice, and for 30 hectares we are using for vegetables. We are using more number of vegetable as it is high revenue generating, and we are using less rice for hectares as rice uses more number of liters of water. So from here we are getting the profit of the total profit of here we are getting is 23 lakh 50,000. Now moving to the next slide. The results are the total water that we have used is 296 million liters of water. That is not more than 300 million liters of water. And the total land we have used is 50 hectares. And the total water that we have calculated for wheat is 4.5 million liter multiplied by the number of hectares that we have used for wheat cultivation. So for wheat, we have used 56 million liter of water, and for rice, we have used 6 million liter of water, and for vegetables, we have used 180 million liter of water. Now we are going to calculate the budget, that what cost we are getting. So for wheat, If 55,000 is used per hectare, so if we multiply the number of hectares, then cost for wheat is 6,87,500, and for cost for rice is 5,25,000, and for vegetable it costs 2.4 million. So total cost is 36,12,500. Now the land allocation is for wheat we have used 12.5 hectare, for rice we have used 7.5 hectare, and for vegetables we have used 30 hectare of land. Now revenue. So from wheat we are calculating revenue of 7,20,000, and from rice we are getting 7,42,000, and from vegetable we are getting 45 lakh. And the total revenue we are generating is 59,62,500. Now if we subtract total revenue minus the total cost used, then we are getting the profit of 23,50,000. Now from here, my friend Akash will tell the scenario if water availability lost by 10%.
Good morning and Jain everyone. I am Akash and now I am going to tell you the scenario analysis when the water will be 10% less than the case. So in this case we have 3 million liters of water. But if we reduce 10% of water, that is 30 million liters, so we will only get 270 million liters. The land. Next. So the some sustainability and crop rotation criteria are the wheat improves the soil nitrogen component, and vegetables increases the soil organic matter, but rice uses high amount of water and do the methane emission. So we should use different types of crop rotation to balance the all three sustainability goals. And the first one is we can grow legume cover crops after the use of rice, and then we can grow wheat. So the nitrogen content and the soil organic matter should be in the control, and also the methane emissions should be less. And the second sustainability criteria is that we should use a crop rotation method within 2 or 3 years in each plot, so all plots get the nitrogen component easily. And by next we can. And in the recommendations and conclusion, we can say that in short term, we can use vegetable because they make us very best revenue out of all three crops. And in water saving, we can install drip irrigation and improve scheduling to increase water efficiency. And then we can also reserve some part of land because due to pest attacks or some drought situation, our crops maybe go to failure. So we should keep reserve land to manage our uh, revenue and also our yield. And in conclusion, we can say that if we allocate 7.5 hectare for rice, 12.5 hectare for wheat, and 30 hectare for vegetable, we can get the best budget efficiently method to grow all three these with the help of very less water. Thank you, NJ.
I have a question for you. Am I audible?
Yes, ma'am.
Okay. So you had talked about the water when it drops by 10%, right? What about revenue? What will be the effect on the revenue if water drops by 10%?
We can show it by PPT.
Yes.
In the PPT, we have prepared the slide. Like if we are using water, so if the water drops by 10%, so if we we are calculating the total cost, that is 32 lakh, and the profit that we have calculated. So revenue generated in if 10% water drops is 47 lakh, and in the base case, we have get 59 lakhs. So the revenue drops from 59 lakh 62,000 to 47 lakh. So we can, the revenue drops from this.
Which formulation are you using over here? What is it called in mathematics? The constraints and all what was given to you? What formulation is it?
Ma'am, we are directly multiplying the number of hectares by the water
No.
use.
No, I'm talking about the total formulation that you had, land, water, budget. What was that? What is that called?
No idea.
This was a linear programming problem, basically, which you will be studying in class 12. So what is a linear programming problem? That is to optimize the given particular whatever data that has been given to you, subject to constraints. So you had constraints over here, like land, water, and budget. These were your three constraints. So it had to be less than 50, it had to be less than 300. So those were your subject to constraint, and you had to maximize revenue. So that was your linear programming problem. Yeah. So you need to study on what particular topic you're given, what are these subject to constraints that is given to us. So you had to formulate a linear programming problem, basically.
Also, I have one more question.
Yeah.
What do you understand by smart farming?
And smart farming is a process in which we use sustainable methods to reduce the water that is used for the irrigation. As we know that sometimes we use more water in irrigation, so it also creates water logging and it wastes water. So by there are some methods from which we can reduce the irrigation, and we can use the product like drip irrigation method or sprinkler methods. In it is uses more, less amount of water.
Ma'am, I can also tell that smart farming also means that we should do farming with the help of new technologies that are coming. Like in other countries, the drones are used to spread fertilizers on the field, and nowadays planes and other technologies are also used. And now GPS is also used in the farming to do to find the weather. Then when we have to grow the seeds and when we have to give the water to the plants. By using the technologies, we can also do the farming. So that is also called smart farming.
How can you connect maths with smart farming?
Ma'am, can you repeat, please?
How can you connect maths with smart farming?
Ma'am, we can connect how much water we should use to cultivate the particular crop, and we can also use that scientific research that in the mathematical way, that how much fertilizers we are using, putting in the soil tests about this to maintain the pH of the soil, that which our crop will grow at very good growth.
Yes, Arun sir, do you have a question for them?
Yes, ma'am.
Yeah.
First, thanks to Brahmagupta team for selecting the topic from the agriculture. Amongst you, who is belong from the farmer family? Out of who?
Say you're not audible. Say you're not audible.
The three of us family does farming.
Okay, then good. There is a slogan. The future belongs to nation with grains and not guns. The future belongs to nation with grains and not guns. Who says this? Who quote this?
Can you repeat?
Sir, not audible, sir. Can you repeat one more time?
The future belongs to nation with grains and not guns.
Sir, we are not aware about it.
Are you listen the name of Dr. M.S. Swaminathan?
Yes, sir. He was the father of the Green Revolution, which
Then
gives us modern farming techniques.
good. Next question. There is a plan of Government of India about the irrigation, as you discuss in your slides everywhere. What is the name of that plan scheme about the irrigation?
Sir, are you talking about the ways that we can irrigate the land, like sprinkler method, drip irrigation?
What is the name of that scheme?
Scheme, sir, we are not aware.
Are you listen? One drop more crop. One drop more crop. That's why I'm saying with the team cosmetics and also Brahmaputra, please read better. A lot of data you read before making any case study or any presentation. Reading is important. One drop more crop. Please be remember. And next question, rice, as you mentioned. This is the which season crop?
So this is monsoon season crop.
What is say in the language of agriculture?
Sir,
Yes.
Khan.
Huh? What is and wheat
Rabi.
and vegetables?
Vegetables are grown in every season. They vary. Different vegetables grow in different season.
How
Like
many
spinach is
agriculture? How many agriculture season you learn or listen or read?
Three.
Which one is the third?
Jad crop.
What we grow in that season?
In that
Fodder crops.
fodder crops are
Fodder
grown
crops
like
are
and cashew.
For
that
example?
is-
For example?
Persimmon.
and
Okay. There is also a scheme PKVY. P for Patna, K for Kanpur, V for Vellore or Vikas, and Y Yojana.
प्रधानमंत्री कृषि विकास योजना सिंचाई
Paramparagat Krishi Vikas Yojana. What you say? Paramparagat means
परंपरा like traditional methods we are
that's
using.
traditional agriculture system. Okay. And what is Kisan Samman Nidhi?
In which the government helps farmer by providing funds and like rolling
How
their
much
goals.
amount? How much amount government paid in the farmer account in a year?
According to land, I think how much land the farmer.
No. 6,000 in a year. 3 times 2,000, 2,000, 2,000. In a year, total 6,000. Government, what you say, the scheme, direct DBT, direct beneficiary scheme. Last question. As you hear about the news that Trump apply the tariff on India 50%, which agriculture product is most hampered, or in other ways say that which agriculture product India export to the America? Maximum export of which agriculture products?
Maybe some rice.
No. There is no tukka. If you know, then say yes. Otherwise, say sorry. This is also important to read, to learn, to listen the news. Fisheries. Okay. Rest, good. Your presentation is good. Your selection of topic is good. But do some more studies before writing, before preparing the slides, PPT, anything. Okay, good. Thank you, ma'am.
Let's move to our last team. Any?
Actually, we were having a question regarding this.
Okay.
So-
Yeah. Sorry. Team Acoustic and Team Cosmetric had to ask questions. Yeah, please.
Yes,
we've
ma'am.
seen
Yes, ma'am.
that, this model profit is maximized with land, water, and budget constraints. But if we measure profit per liter of water use instead of total profit, which crops become the most efficient, and how would that change the cropping plan of this?
Vegetables are more efficient to use as it requires less number of water used and it generates more number of revenue as we have shown in the PPT and data. And there we have shown that it uses less water and it generates more revenue than the other, and it benefit the soil like because of the rice plantation, rice emits emission that reduces soil fertility. So after planting rice, we can plant vegetables or legume covers like we can plant legume like crops like pulses to reneutralize the soil, so it increases the fertility of the soil.
Ma'am, but this data you are providing is already given. But what our question is, if you optimize for profit per liter of water, which crop should dominate, and how your like your project, how the land allocation will change regarding this?
We are not getting a question. You can repeat.
Saying that if you are changing, if you will go for the like profit for the per liter of water, okay, so not total profit, which crop should dominate, and how would you recommend your land allocation change?
Vegetables only. It is generating 25,000 rupees per hectare per of million liter.
I think there is some misunderstanding. I'm just asking for the how would you change the land allocation regarding this?
Allocation. Can you suggest some method? We are not getting
It is like that only. It is like that only we have created that because vegetable is producing 25,000 rupees profit on per million liters, and rice is producing 12,335 rupees profit on per million liters, and wheat is generating 12,800 rupees profit per million liter. So in that way we can also put vegetable on the top because it is like double of the other crops that are producing the profit. So by that method of the land allocation, we should also keep we can only keep vegetables on the top because it is only producing profit more.
But a water efficiency objective would prioritize vegetables, then rice, and likely minimize or drop wheat unless needed for rotation, soil health, or to meet budget land constraints. And my question also exposes that wheat's profit per hectare is only 2,600, so it barely above cost, making it the least water efficient choice under the scarce water. All
as
these figures are derived from the
as
project.
rice is using more number of water, and rice also releases some emissions like methane emissions that decreases the soil fertility, so we cannot plant more hectares of rice as it will degrade the soil fertility.
No more rebuttals, only one rebuttal is allowed.
Okay, ma'am, we are satisfied with the answer. Thank you.
Yeah, Team Cosmetric, do you have any rebuttal? No? Okay. We move ahead to our last team, Team Acoustic Delta. Yeah, and please adhere to the time. You only have 7 minutes.
Hello, ma'am.
Good morning once again. I have a question to the team. Why should the farmer avoid planting only the most profitable crops every season?
We must not look to the revenue. We must look to the soil. What is soil is demanding? Like we are for what purpose we are sowing? Like if other farmer like the market price and the availability of water and like for if there some field are there and the availability of water is less, so we cannot so it is clear that we cannot plant rice because it uses more number of water. And like if the availability is more, so we can plant vegetables and rice there. So it depends on the soil and the demands that they are getting.
Okay, let's move to Team Acoustic Delta. Thank you, Team Brahmagupta.
Okay. So a very good afternoon and Jai Hind to everyone. Today the team Acoustic Delta is here for the presentation of our case study, whose main idea is Eco Water City. And our topic is mathematical modeling of rainwater harvesting in Jaipur. So basically, Jaipur is a city which experiences a severe water shortages in summer season. And while in monsoon seasons, a large amount of rainwater is run off. So here we use mathematics. Here we use mathematics to create an efficient rainwater management system. And our main objective is to use mathematical calculations for creating an effective rainwater management system that can ensure sustainable city. So now, talking about the importance and applications of mathematics in our project. So here we have used mathematics to calculate rainwater, analyze tank costs, and calculate maintenance costs. It makes our project data-driven and effective for water management. Now, coming to the next slide, which is catchment areas and rainfall data. So, catchment areas refer to the areas which are affected by the rainwater runoff. So, here we have chosen three areas, which are school, market, and hospital. The reason behind choosing these three places is because these three places have a rooftop, require sanitation, and are public areas where a good system of rainwater harvesting is required to promote sanitation and a sustainable area. So here we have three considerations: the roof area, average annual rainfall, and runoff coefficient. So runoff coefficient is a dimensionless value which is used to determine the amount of rainfall that is going to be harvested, because rainfall not only contains water when it's run off, it also contains some soil particles and also it contains rocks. So here it is given that for school we are having 0.8 as runoff coefficient. So 0.8 means 80%, that is 80 by 100. So it becomes 0.8. Respectively, we have 0.85 for hospital and 0.75 for marketplace. For marketplace, we are having the least 0.75 because we and everyone knows that marketplace is a crowded area which contains kacha roads made up of soil and all. So that's why it contains a large amount of silt and soil in the harvested rainwater. So there's only 75% of the rainwater is going to be harvested. Now, from here, my friend Atul will carry forward.
So now I am here to talk about the rainwater collection calculation. In this, we will generally use a formula that is volume in liters is equals to roof area in meter square into rainfall into runoff coefficient into 0.001. Runoff coefficient refers to the ratio of runoff water to the total water. And we use 0.001 to convert the volume in liters to meter cube, because meter cube is more standardized unit and it makes larger number of volume into smaller numbers. Like if we take 10,000 liters, it can convert into 10 meter cube. And like that, it also helps in easy calculation. We calculated the water that can be collected from different places, that are school, hospital, and market. In school, we get to collect 1,056 liters. In hospital, we get to collect 1,870 liters. And market, we get to collect 1,237 liters. In market, we can use rain barrels, wings, and overhangs to collect the water. The hospital majorly contributes the maximum share for collecting the water. Now, next slide is tank allocation plan. Our objective was to store at least 80% of the collected water. For example, required storage for the school is equal to 0.8 into 1056. Here 0.8 means 80% of the water collected in the schools. That is 80% by 80 by 100, that can be converted into 0.8. Similarly, we calculated for the hospital and the market. Then we planned tank allocations accordingly. In like that, in school, required storage in liter is 844.8. Like it means 80% of the total water collected in the school, that is 1,056 liters. And tank size would be 1,000 liter and total cost is 25,000. Like that, hospital and market is there and total cost would be 80,000 rupees. Now, we will talk about the maintenance and budgeting, because maintenance plays a very crucial and a vital role for budgeting a plan and a project for a better use. In this, the total budget for tanks was 4 lakh rupees as provided in the case study by ma'am, and maintenance cost is assumed as 10% of the tank cost. For example, if one tank costs 25,000, maintenance would be 10% of 25,000, that is 2,500 rupees. Overall, maintenance must remain under 15% of the budget, that is 60,000 rupees. This ensures sustainability without overspending. It means that it involves regular monitoring, effective resource allocation, and strategic planning, which ensures a better use and a safeguard for the water for a better use. Now, from here, Anubhav will continue.
Okay, so to conclude, to conclude, using mathematical calculation is the most viable solution for Beppu's problem water crisis. Also, our plan maximizes storage capacity, tanks allocations, and it leads to budget constants that reduces the budget for maintenance. So now here we are having a what-if scenario. We also know that rainfall is an unpredictable thing, which is not accurately predicted till now. So if the rainfall decreases by 20%, so whatever calculations which we have used can be again calculated. That is, for new volume is equal to the new value into 0.8, that is the 80%. So now from this we conclude, and now I would like to tell the sources for which we have used to make this PPT. First is Canva for theme. Second is the digitalsansad.org website for the government schemes and the pre-given case study for the suitable data values. Here we have also implemented graphs and tables to make the calculations and data values looks more easier to understand.
Thank you.
Thank you, Anjay.
Okay, good information, Team Acoustic. But you did not compare the three kinds of tanks according to the cost efficiency. Which tank would be better to use? How many liters? Yeah.
Actually, we have not compared it on the PPT, but we told you that for marketplaces we are using rain barrels along the overhangs and awnings. For schools and for hospital, we are using tanks whose capacity is around 1,000 liters. We are not directly implementing tanks in marketplaces because it is not practically possible. So we are there implementing rain barrels, which are more efficient and effective in those type of areas.
Okay. And which India state has made rainwater harvesting compulsory? Which Indian state? Which Indian state has made rainwater harvesting compulsory?
Tamil Nadu.
Good. So you researched it, you had gone through it?
Yeah, means we went on digital Sansad app, so from where we get to know the bit of schemes and uh, NGOs like live along, and try to live the art of living. So from there we get to know about all these things.
Oh, good. Yeah, Arun sir, have any questions?
Yes, ma'am. Thank you. Team Acoustic Delta. Are you seeing the tools, instrument through which measure the rainwater? This simple question
It is rain gauge. Rain gauge.
Yeah?
It is used to measure this. Is rain gauge.
Rain gauge.
In mm.
Okay. Are you seeing this instrument?
Actually, I have seen the picture. I've studied in previous classes in class 7.
In your school, there is a geography lab. Are you visited any time in the geography lab?
Yes, sir, I have visited.
Then what you see there?
Actually, I haven't noticed the rain gauge, but I have noticed some of the solar systems, the class of solar systems, sun, moons, and the
This shows
maps which
that
we are
you are
having.
not alert. Okay. And what is the other name of this rain gauge? Scientific name of this rain gauge?
So I'm not aware about it, but I will search it later.
Eudometer. Eudometer.
Thank you, sir.
Okay. The rest things are good, but one thing more, reading is important. Before collecting this data, read more better. Make a habit. This is a lifelong learning. Anything is not a waste, but do more research. Then your data must be more weighted and valid. Okay, good. Best of luck.
We will definitely look into it, sir.
Nidhi ma'am.
Yeah. Team, I have a question. Rainwater harvesting system is planning is done before the rainfall or after the rainfall?
Actually, ma'am, if you see in the current situation, then we have already seen many worse situations. Like if you see in Baliya only, then in this year in Baliya, the rainfall was very less. But then also in many areas we felt flood. It is because of Narora Dam situated in Bulandshahr. So this shows that rainwater harvesting is being done, but it is not. But it is only done in the big cities. So for rainwater harvesting, we need to have a pre-plan, because if you are going to wait for the worst situation, that is going to make the situation more worse. We can't wait for the worst. We have to be prepared for the circumstances or calamities before only.
Okay. And on what circumstances is it planned? Like, what are the criterias that we have to be prepared for the rainwater harvesting? Like, how much we have to store, or what instruments or what plannings we have to should be done? It's depend on what criteria.
Actually, yeah, that is only the runoff coefficient, because you and me, everyone knows that the rainwater not only contains water, it contains soil and silts also. So that is only runoff coefficient, that how much percentage of the water is going to be harvested, which we have written in our tables, which you can see. That is 0.8 for the schools. That is 80% of the rainfall is going to be harvested. So for this, we can use the data because many situations have already occurred from which we can use statistic and calculate data required for it.
Okay. Does only data's work or the area also work?
The area and data also work because data helps us to find the probability that how much rainfall means there's probability that how much rainfall can be harvested. Because rainfall is not predicted. It is not accurately predicted.
Yes.
It changes
So,
from time to time, from second to second.
yeah. So data and area both goes parallel, that right? While planning
Yeah.
this.
We can the only thing possible for us is using data. So we have to use whatever possible.
Good.
And why rainwater harvesting is important?
Water harvesting is important in many ways because if we to prevent floods, it is also required to stop the depletion of water tables. And it also that also for clean sanitation, that is SDG 6, clean water and sanitation. If rainwater harvesting is not done, then it would lead to bad sanitation, which should create a large amount of or diseases like diarrhea and or cholera, which are easily affected due to bad sanitation, which is done due to bad rainwater harvesting. Our government is also promoting some schemes like Rajiv Gandhi Clean Water. This was the first scheme launched in 1991 to promote clean water, and their plan was to do rainwater harvesting. Through rainwater harvesting, they were going to do clean water or provide clean drinking water to each and every citizen of India.
Can you suggest some policies for rainwater harvesting, like what what can be done for
Can you
promoting
please repeat the
rainwater
question?
harvesting? Can you suggest some suggestions that what should be done to promote the rainwater harvesting?
Okay, so to promote rainwater harvesting, okay. So the main thing is absorbance. I told you that here we have chosen three places: school, hospital, and market. So school, hospital is the other area which are well educated, where people visit there are well educated. So if the people who are economically backward or educationally backward, if they will see that through rainwater harvesting, the condition and the sustainability of these places have been improved. So this will lead to an absorbance and it would create a scenario in their mind that rainwater harvesting is very good and efficient for making the city and the area more sustainable. So it would promote. It would indirectly create an awareness only.
So you mean public awareness, right?
Yeah.
And do rooftop harvesting helps in this?
Yeah, rooftop harvesting do help because in India we live in India and the northern plains. We do not have slant roof because snowfall doesn't occur here. We are having a square roof in which water is easily collected, and if we collect those water in tanks, which could be easily used for future whenever any bad circumstances or calamities occur. So it is the most efficient way to collect rainwater in our homes and majorly in our region.
Good, good.
Okay. Now let's have questions from Team Brahmgupta and Team Cosmetric, if they have any.
I have a question, ma'am.
Yes, please.
That how rainwater that we have conserved can provide sanitation.
Okay, so how river can provide sanitation? So it could tell me one thing, that when flood occurs, flood takes away all the things. We are having um, okay, yeah. When a flood occurs, it takes each and everything along with it. Majorly the sewage water, and everyone knows the sewage system in Baliya is very bad. Majorly the Qatar Nala. So if the sewage system is very bad, it would take it along with it, and it would create a bad sanitation. That's why I included SDG 6, that is clean water and sanitation.
We are not asking that question. We are asking that we are the rainwater that we are conserving the water of rain. how it is clean and how it can be used as for living life, like how it can be used.
We can filter it. We can filter it for future use because the
Like
fresh water is very less, and the rainwater is rich in minerals also.
like the acid rain occurs, like many times the acid rain occurs and water is very acidic, and how it can be used.
That's why only the process of filtration is invented. That's why we use filtration.
We can also have another pipe for throwing out the water.
We are not
which is
directly
acidic.
we are not using that water directly. We can chlorinate it, or we can even filter it.
We can add chlorine gas in it.
There are wastewater treatment plant in which we can also build rainwater treatment plant in which rainwater can be treated and then supplied to whole city.
We can
through a
also
system of well-developed pipelines.
Because we can also use traditional ways of filtration that you have studied in class 9 geography book.
Yeah, we can use stones,
Gravels.
coals which are easily available.
Okay, okay. Let's have team cosmetric. One rebuttal only, no cross questioning, please. Team cosmetric.
How will you ensure hello, ma'am. There's a question by me.
Yeah.
How will you ensure the sanitation of the underground rainwater storage tanks?
Okay, so how can we ensure the sanitation of underground rainwater storage tanks? So I included one thing in my PPT that we are going to use tanks. We are not going to build tanks. We are going to use tanks. Okay, so we are not going to make underground tanks like septic tanks and all. So it can be easily cleaned. We are having tanks at our homes also, which is easily cleaned. It's not like it cannot be cleaned or sanitated.
Okay, fine. Any other questions?
Well, I think septic tanks don't need to be clean because they have the our excreta and all the things. While the water we gotta use, so we gotta make it clean, I think. Correct me if anything is there.
It's not like a septic tank is not clean. It is cleaned if it gets full. So our plan is not to build tanks like septic tanks. We are
During
going
your-
to implement.
Yes, Team Cosmetics, Brahmagupta and Aquastic. During your lunch time or during the dispersal time, please discuss on this important topic. Okay, make a habit to utilize your free time. Okay, good.
I think we can conclude. And thank you, Sneha ma'am. Thank you, Sandeep sir. And thank you, the three teams and Arun sir. Most importantly, thank you so much.
We also thanks you, ma'am, and Nidhi ma'am, for guiding us and our students, motivating my team and all the mathematicians of SunBeam Baliya. A lot of thanks, ma'am. Jai Hind.
Yeah, Jai Hind, sir. Jai Hind. Thank you.
Jai Hind.
Jai Hind.